Okay, so we looked at two shapes that we saw from a prior project. This shape and
This shape.
this shape. Now this shape gave some trouble. We have disagreements on the number of vertices, edges, and faces.
Oh, yeah.
Okay, so we're going to have to figure out how we come to an agreement on that. But what about this shape first?
That shape seems to follow the Euler's formula.
Okay, so how many... here, you know what? I'm going to move the whiteboard away since the shape itself is white.
Right.
How many vertices are there?
So there are 14.
Okay, and how many edges?
There's 24.
How many faces?
12.
12.
Okay, and what do you find?
14 plus 12 minus 24 is indeed 2.
Okay, is indeed 2. All right, so this interesting shape that we found in a project actually from Alexander Bogomolny
Yeah.
seems to satisfy Euler's formula.
Right.
This shape, on the other hand, the complement, this is the shape when you remove this from a cube. So this is what's left over. This shape gave you guys a little bit of trouble. Here, hold that so it doesn't fall over. So you counted 18 vertices, 24 edges, and 12 faces. You counted 20 vertices, 27 edges, and 12 faces.
Yeah.
Yeah.
Okay, so even just counting how many vertices and edges there were was pretty tricky. Yeah, but at least you agreed on the number of faces. So that's good. But what is the problem in either one of these cases?
Well, they don't work.
No.
What do you mean they don't work?
Like, they don't satisfy the formula. Like, in this first case, 30 minus 24 is not 2.
Okay, so in this case, we get 30 minus 24, so we get 6.
And in my case, you get 5.
We get 5.
I'm pretty sure that this is wrong. The edges, but
Okay.
I'm not sure about the vertices.
All right, so what we're going to do to resolve this is we're going to build this shape out of Zome, and we're going to count the struts. Now that's going to change things a little bit because what was one face here is going to be chopped up into several faces. But that's okay, that shouldn't change the Euler.
And we're in agreement on the faces anyway.
Well, but let me just real quick show you that if you have something like this, so I have 4 vertices. Sorry, 4 vertices, 4 edges, 1 face.
Yeah. All right.
And I chop it into 2 bits. I get now 6, I'll say these are the vertices, say. 6 vertices. Before there were 4 edges, now how many are there?
So
This would count as a new 5th edge. Here. Well, or would these count as separate edges now?
How many edges are there? Pretend that's made out of Zome.
So I count this as 1, 2, 3, 4, 5, 6, 7.
There's 7. And how many faces are there?
well,
2.
2. Okay, so here we have vertices, edges, faces. So 5 minus 4 was
So
1
1.
before.
8 minus 7 is 1.
8 minus 7 is 1. So in the calculation, even though we're not getting 2 here, but that's a different story. But when you chop up something into 2 pieces, it doesn't change the faces minus edges, vertices minus edges plus faces formula. So when we build something out of Zome, we can actually count all the balls as vertices, all the struts as edges, and then we just are going to have to be careful to count the faces properly.
Yes.
Alright.
Okay?
Right.
All right, so go build this shape out of Zome.
Okay.